Hello everyone, welcome back to my YouTube channel. So today let us discuss about the direct memory access DMA. So let us start with the introduction. DMA is a future of computer systems that allows certain devices to directly access the computer's memory without the intervention of the CPU. DMA significantly improves data transfer speed and efficiency by reducing CPU overhead. DMA is commonly used in devices such as sound cards, network cards, and graphic cards. So, how DMA works? DMA controllers are responsible for managing data transfers between devices and memory. So, DMA controller initiates data transfer by sending a request to the CPU. Once the CPU approves the request, the DMA controllers takes control of the bus and transfer the data directly between the device and the memory. So let's see the advantages of DMA. Increased data speed, reduce CPU overhead, improved system performance are the advantages. So it eliminates the need for the CPU to transfer data, resulting in faster and more efficient data transfer. With DMA, the CPU can focus on other tasks while data transfer can occur independently. DMA allows for concurrent data transfer, optimizing all over system performance. So let's move on to the types of DMA. Single channel DMA, multi-channel DMA, scattering gather DMA are the types. So in single channel DMA, single DMA controller manages data transfer for one device at a time. In multi-channel DMA, controllers handle data transfer for different devices simultaneously. This type allows for non-contact-based data transfer, improving flexibility and efficiency. So let's move on to the data process follow. So in device initiates a DMA transfer by sending a request to the DMA controller. DMA controller requests access to the system bus from the CPU. So CPU acknowledges the request and grants access to the DMA controller. So let's see the common applications of DMA. Audio and video processing, network communication, disk input and output operations are the applications. So DMA enables high quality audio and video streaming by efficiency transferring large amounts of data. So in DMA improves network performance by uploading data transfer tasks from the CPU to dedicated controllers. So DMA facilitates fast and reliable data transfer between the storage devices and the memory. So let's move on to the limitations of DMA. Limited address space, device compatibility, increased complexity are the limitations. So DMA can only access a specific range of memory addresses, which may restrict its usage from some scenarios. Not all devices support DMA, limiting its acceptability and applicability to certain hardware configuration. Implementing DMA requires additional hardware and software support, adding complexity to the system device and the development. So the next is DMA and CPU interaction. DMA and CPU work in parallel, allowing for simultaneous data transfer and CPU processing. The CPU sets up a controlled DMA operation by configuring DMA controllers and providing necessary instructions. So, DMA interrupts the CPU once data transfer is complete or when an error occurs requiring CPU intervention. So, let's move on to the DMA transfer modes. Burst mode, cycle stealing mode, transparent mode are the modes. So, in burst mode, DMA transfers data in burst, taking advantages of the high speed capability of the system burst. So, in cycle stealing mode, the DMA temporarily halts the CPU's access to the system bus to transfer data, minimizing CPU interventions. So, in transparent mode, DMA transfer data without the CPU intervention, allowing the uninterrupted CPU processing. So let's see the DMA channel. DMA channel are independent pathway that allow for concurrent data transfer. So each channel is associated with specific device set of a device. So the number of available DMA channels varies depending on the system architecture. So let's see the programming DMA. Programming DMA involves the configuring DMA controller, settings up memory addresses, and specifying transfer sizes. So, DMA programming can be a complex and requires knowledge of the specific DMA controls registers and configuration options. So, DMA programming can be done using low level programming language or specialized APIs provided by operation system. So, the next is DMA contention. So DMA contention occurs when multiple devices request access to the DMA controller simultaneously. So DMA controllers prioritize requests based on the predefined criteria such as channel priority or time of arrival. So proper management of DMA contention is crucial to avoid data corruption or delay in data transfer. So the next is DMA security considerations. So DMA poses potential security risk as it allows devices to directly access system memory. So DMA attacks such as DMA based memory scrapping can be mitigated by using techniques like input output memory management unit, that is IOMMU. So IOMMU provides memory isolation and access control, preventing unauthorized access to sensitive data. So let's move on to the DMA evolution. So DMA has evolved over time to support faster data transfer and accommodate changing device requirements. So modern DMA controllers offer advanced features like scatter, gather, bus mastering, and virtual memory support. So DMA continues to play a crucial role in improving system performance and enhancing device capabilities. So at last the conclusion, DMA is a key technology that enables efficient data transfer between a device and memory in computer systems. So DMA reduces CPU overhead, improves system performance, and enhances data transfer speed. So understanding DMA principles and consideration is essential for optimizing device performance and ensuring system security. So thank you.